Static methods, static fields, and class math. We're now going to discuss the concept of static in more detail, starting with the concept of static methods, which are also known as class methods. And the reason they're known as class methods is because they tend to apply to the class as a whole, as opposed to a particular instance or object of the class. In fact, some people refer to the non-static methods of a class as instance methods because you must invoke them on a particular instance of the class. Now, we introduced the concept of static methods in the context of the math class's POW method, which raises a base to an exponent. And we saw that with a static method, you can invoke the method by specifying the name of the class, a dot separator, the name of the method from that class, and then its set of arguments in parentheses. Now, if we revisit the online documentation for class math once again, and we go to its method summary, you can see that all of these different methods are declared static in the math class. And that's important to you as you're browsing through any class's online documentation, because every single time you see the word static in front of a method definition, you know for a fact that you can invoke that method via the class name of that class. As another for example, take a look at the integer class in the java.lang package. Now when I go to the integer class's method summary and I scroll down a bit, you'll see that one of the methods that I have available to me is this method named parseInt. It takes a string as its argument and gives me back an integer. Now I don't have to have an integer object on which to invoke this method. It's basically a utility method that allows me to convert a string to an int value. And the nice thing about utility methods is that I don't need to first create an object of the class that they belong to. Now, this is a pretty common occurrence throughout the Java APIs because in Java you're not allowed to have globally defined method definitions. Every single method definition must be placed into a particular class. So in this case, because the parseInt method is really geared towards an operation that has to do with the int data type, and because class integer is where Java encapsulates all the functionality for manipulating integer objects and int values, they've put this method into the integer class. So as you design any given class, one of the things that you need to think about is whether or not the method that you're defining needs to operate on the state of a given object. If the method doesn't modify the instance variables of a given object, then the method probably can be a static method of the class, thus making it usable to anybody with access to your class. All they have to do is name the class, follow it with a dot separator, and then invoke the appropriate method. Switching back to my slide now. So for example, here we have the math class's square root method with a sample call in which we'd like to invoke square root with the value 900. We certainly don't need a math class object to tell square root that we want it to calculate the value of the square root of 900, so we simply pass it to the static method square root in this example. And we'll see many other methods like this as we study Java. As I've mentioned before, whenever you learn a new class, one of the first things you should do is read the online documentation for that class, look at the method summary for that class so you get a sense of all the capabilities of the class, and then make sure that you look now as well for the static keyword so that you can see some of the class's utility type functionality that you may be able to take advantage of without creating objects of the class. Now let's focus on the concept of static fields in a class. A static field is actually a variable that's declared inside of your class preceded by the static keyword. Often such fields are also declared as final, which enables you to indicate that the field should remain constant at all times. As a for example, let's take a look back at our math class in the online doc set, and you'll notice that there's a summary link for fields of the class. Now, the field summary of a given class is going to show you both the instance variables of the class and the static variables of the class, which are also known as class variables. And the reason they're known as class variables is that all objects of the class would share the class variables that are declared within that class. So if I had a class with a class variable declared and I created thousands of objects of that class, they would all share the one static variable. Now in the class called math, we have actually two constants defined as static double variables. One is called e and one is called pi. And for example, if we click on the link for pi here, we can see the complete declaration of the variable pi that they use in the math class. It is a double variable. It's placed in all capital letters by convention. Anytime we define something as a constant, we do that to make it stand out in a program. We declare it final because we don't want the value of pi to change. And since this is always going to be the same value, there's no need for there ever to be more than one copy of this named constant, if you will. So for that reason, it's also declared static. Often final variables are also declared static so that there's only ever one copy of them. And in this case, it's a public variable. Now, in an earlier example, we said that you shouldn't have public data. But when you're defining a constant, something that can't be modified, often such a variable will be made public so that everybody can make use of it in their programs. And that's actually a common way to declare named constants in your code. So for the concept of a static field, the term field actually applies to all variables defined within your class, and within the concept of a field you have instance variables and class variables. The static fields are the so-called class variables, and again in the math class we have math.pi and math.e as two constants that we could use in mathematical calculations. Now you may be wondering why it is that the method main is actually declared static. And the reason is so that it can be invoked without you ever having to create an object of your class in which main is declared. In other programming languages, main is usually a globally defined function, for example in C or C++. But in Java, even main has to be wrapped inside of a class definition. So what we need to be able to do is load the class that contains main and invoke main as kind of a bootstrap mechanism to launch the application. So when I go to a command prompt, for example, and this is back to the very first example we covered, and I type Java followed by the name of the class that I want to execute, what the Java runtime environment is going to do is load up welcome1.class into memory, and then it's going to invoke main on that class in order to execute the application. And in this case, again, we've seen it output the string welcome to Java programming. So main has to be statically declared so that the Java runtime is capable of loading the class and invoking the main method on the class that you specify. Now, any class that you ever define can contain a main method, but the only one that matters is the one that you specify in the command prompt when you say Java followed by a class name. So if you have a multi-source file program, every individual class that you define in those different source code files could potentially contain main, and some people actually build main into lots of class definitions as kind of a self-testing mechanism. They might provide their test cases inside the main method to demonstrate that the functionality of the class is working correctly and simply ignore main when it comes to executing the real application. So the JVM is only going to invoke the particular main method of the class that you specify as an argument to the Java command. And similarly, if you're using a development environment such as NetBeans or Eclipse or some of the many other ones that are out there, the development environment is typically going to want to know what the so-called main class of your application is. If only one class in the application has a main method, the environments are typically smart enough to figure out which class is the main class. However, if you had multiple main methods across many different class definitions, then it will expect you to select the appropriate class as the launch point, and then when you tell the development environment to run your application, it will load the appropriate class and invoke its main method.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.